Hey guys, how we going? The purpose of this video is to look at what ions are and how they form. And this sort of, if you have watched the other videos from the early ones about atomic structure and periodic table, they are definitely necessary before you move into these. So we're going to talk about, we've talked about atoms and what they look like. We're now going to talk about what these things, ions, are and how they form. The best way I can think of doing it is to sort of keep bouncing off one of those elements we've already started talking about, which was sodium. And we sort of learnt the other day or in the other videos that sodium, like every other atom, has a nucleus, and inside that nucleus we have some protons and some neutrons, and then around the outside we have electrons. And those electrons exist in shells. Think of them sort of like houses with rooms. And those shells only can fit certain numbers of electrons. We also remember that each element has a symbol, so sodium is Na, and we record the number of protons that are in the nucleus, like so, and so sodium has 11 if you check your periodic table, and we also know that the mass number is the number of protons plus the number of neutrons, so we're going to record that as 23. So that all exists within the nucleus, the protons and the neutrons. We also remember that in a neutral atom, this guy is neutral. So far, I want him to be neutral. In a neutral atom of sodium, if he's got 11 positive protons, so if he's got a positive nucleus with 11 protons in there, he must have 11 negative electrons so that they can cancel out. So the first shell, 1, 2, and then he's full. And the next shell can fit 8, 2, 3, 4, 5, 6, 7, and 8. That makes 10 all up, and so we need to use the third shell to have one more. And so that gives us 11 electrons total, which balances out our 11 protons. So we have a neutral atom. We also remember that we can write the electron configuration for this sodium atom, which is 2 in the first shell, 8 in the second shell, and 1 in the third shell. And finally, remember that last one, that 1 in the third shell, is really important. He's called the valence electron, and that's the guy that seems to dictate a lot of the chemical properties that these atoms will have, how they react, how they interact with other atoms, what sort of things we can make with them. That guy's really important, that valence electron. So look, that's revision, and that's how we can draw a sodium atom. Now, chemists are lazy, and we don't often like to draw these sort of models as detailed as that, because as a chemist, you sort of get to know those shells. So to make it really simple, there's another way that we represent atoms a lot of the time, and that's by just writing their symbol, and then we just put some dots around the element. Now, in this case, sodium just has one dot. Now, these dots represent the valence electrons, because, you know, there's all these other electrons in sodium that they're there, but we don't care about them when we're looking at things reacting and forming what we call ions. We care about the valence electrons, because the valence electrons are the ones that are going to have the potential to be lost to somewhere else, or possibly some more gained into that shell. So we only focus a lot of the time on the valence electrons. So this diagram here, this is called a Lewis structure. Okay, it's called Lewis structure, and Lewis structures only show the element symbol and dots for the valence electron. So sodium only has one valence electron, so he has one dot. So this guy is, like we said, a neutral atom. He has 11 protons and 11 electrons. So if he has 11 positive charges and 11 negative charges, he's going to be neutral. Overall, they cancel each other out. But, like we said the other day in the video, sodium does not stay as a neutral atom. We can't actually find this sodium as a neutral atom in nature, because it's so reactive. Remember, these atoms are looking for ways to have full outer shells. Now, you know, that's a simplistic way of saying it, that they're happiest, they have the lowest energy, they're the most stable when they have full outer shells. Sodium currently in its neutral state does not. It has this one electron sitting here that it would like to either get rid of or fill up the shell, and that third shell needs 7 more to fill it up. Now, because it's easier to lose electrons in this case, and again, metals, particularly sodium is a metal, metals will always lose electrons. And in this case, sodium loses 1 electron. Now, he doesn't just lose it to nowhere, something's got to take it, right? There's another atom that takes the electron. We'll talk about who could take that later, but it's somebody takes it. And as it loses the electron, That dot disappears. There's no longer a valence electron there, and we're not going to draw the next shell down for now, but we've lost one electron. So it's no longer a neutral atom because we still have 11 protons like before. Just draw an arrow across. We still have 11 protons as before, but we've lost an electron. So we're actually now down to 10 electrons. We had 11. We've lost one to somewhere else because it's easy to lose them. Sodium's happy to give it away, and it's more stable like that. It's happier like that. So we now have 11 positive charges and 10 negative charges. So we actually have an extra positive charge in this element, or this whatever we're going to call it. We now have a charged particle. It wasn't charged before, it was neutral. Now it's charged. It actually has a positive charge, and we're going to put that up here. So it's an Na+. So it's no longer an atom, it's actually a positive ion. Ion means charged particle. So atoms are neutral, ions are positive, are charged. They can be positive and they can also be negative, as we'll see in a second. So we've formed a positive ion in this case. And this guy, when it's a positive ion, we actually call it a cation. Cation is positive ion. So that's one example. That's sodium. Sodium metal, atom, losing an electron to someone. Now, in the video we watched the other day, it was water. Water grabbed that electron, and that forms a sodium ion. And we've formed that positive ion with an extra proton now than an electron. It's still sodium because the number of protons are the same. Remember, that's the identity of the element, but it's now an ion, and that's formed a positive ion. We're going to do one more in this video. Let's pick a non-metal this time. So this guy, just so we remember, these are metals, or this is a metal, and metals always form positive ions because they like to lose electrons. Okay, so it's really important. Metals, on the periodic table, they're on the left side, and they always form positive ions. So any metal, if you know it's a metal, and then you know that it's going to form a positive ion if it forms an ion at all. Let's do a non-metal now because we can do both sides. So let's pick a non-metal from our periodic table. I'm going to pick fluorine. Fluorine's a good one. It's one of the halogens. He's in group 7 or 17, so it'd be good to find him right now. And so fluorine, just like sodium, has a nucleus. And this nucleus doesn't have 11 protons because that's sodium. He has, let's think about it, I can't see a periodic table right now, so he has 9 protons. So we're going to put 9 protons in the middle there. And then we're going to draw our electron shells in. Now if he has 9 protons, and he's fluorine, he's got 9. Let's say he roughly has the same number of neutrons, so his mass number is 18. So he has 9 protons, 9 neutrons in the nucleus. Let's get rid of that. He's going to have, if he's a neutral atom, which he always starts off as, neutral atom, if he's got 9 positive charges, he's got to have 9 negative charges as well. So he's got to have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So he's got 1, 2, 3, 4, 5, 7 in his outer shell, which gives him 1 free spot. Remember, that outer shell can hold 8, and he's only got 7. So his electron configuration is 2, 7. So he's got 1 free spot. He's not happy, he's not stable, he's a bit unstable, he's actually really reactive, fluorine. Fluorine is like a bully, right? He's going around looking for electrons to fill that spot. He wants to find something that's happy to give that electron up. Now in this case, remember, chemists are lazy. We're not going to draw that again and again, so we're going to draw fluorine, and we're going to draw his Lewis structure. The things that are important are the valence shell. So fluorine has 1, 2, 3, 4, he's got 7 valence electrons. So we're going to put 7 dots, and we do it like this. 1 dot, 1 electron, 2, 3, 4, 5, 6, 7. So we've got 7 valence electrons with 1 spot free. If he can fill that spot, then he's happy, he's stable. So he's sort of like a bully man. He's walking around the lunchtime, he's looking for that lunchbox, he's looking to fill it up, he's looking for that 1 electron. So he wants to, wherever possible, gain 1 electron, just 1, and he wants to gain 1 electron to be happy. And when he finds it from somewhere, somebody provides it, all right? Question mark who that is, but somebody provides that electron. And as he does that, fluorine gains the electron, and we now have 1, 2, 3, 4, 5, 6, 7. Oh, let's put it 7, and let's make it another color so you can see. So wherever he's gained that electron from, it comes into here. And he's now got 8 electrons. In that outer shell, he had 7. He's now got 8. He was a neutral atom. He did have 9 protons, which are positively charged, and he had 9 electrons, which are negatively charged, which made him neutral. That was before he gained electrons. He then went along and gained 1, so he still has 9 protons, but now he has 10 electrons, which are negatively charged. So he now has an extra negative charge. He's got 9 positives and 10 negatives. So overall, he has a negative charge, a -1 charge. So we actually forms, again, he's no longer an atom, he's an ion, and this time he's a negative ion. And we show that negative up here, so -1, and we actually call negative ions anions. Okay, so negative ions are anions, positive ions, like we showed up before, are cations. And this is always, the nonmetals do this, the ones on the right side of the periodic table. Nonmetals, they always form negative ions because they like gaining electrons because they're very close to full outer shells. Okay, so they're always looking to gain 1 or 2, maybe 3 electrons to have full outer shells. So what I've shown you in this video is that atoms are neutral and they have the same number of protons and electrons, but throughout nature, all the time, there are electrons getting switched around. Some elements, the metals, are losing electrons, some are gaining them, the nonmetals, and they transfer them around. And when they do that, when we have a different number of protons to electrons, we don't have a neutral atom anymore. We have things called ions. They'll be positive if they're a metal, and they've got an extra proton or 2 or 3. And if they're a nonmetal, they will be negative in charge because they've got extra negatives, they've got extra electrons. And so we can form these negative ions and positive ions. Maybe I'll just finish off by sort of showing you some examples. So some positive ions that we might have, like we've drawn, is sodium, Na+. Who else is in that group, that periodic table? Because they all have the same number of valence electrons, right? So potassium, lithium's in there, rubidium, cesium, francium. They all form +1, and hydrogen's in there as well. Okay, so they all form +1 ions. Who would form +2 ions? Well, who would lose 2 electrons? So these guys all lose 1 to be happy. Who would lose 2? It's probably the guys in group 2 who have 2 valence electrons, and off the top of my head there's a few in there. So calcium, he often forms +2 ions. Magnesium, Mg2+. What about +3 ions? Well, who's in group 3 or 13? Who has 3 valence electrons to lose to be happy? Aluminium is one of those. Right, so those are some common cations. We also have some common anions. So you can see how the periodic table can be used to work these out. So I'm running out of time on this video, so we'll just quickly do the halogens, who form -1. We know fluorine loses 1 electron. Chlorine's also in there. Bromine, iodine, etc. -2. Who has 2 spots to fill? So fluorine only needed to gain 1 electron. Who needs to gain 2? Well, we can actually look at the periodic table next to the halogens, and the ones who have 6 valence electrons in their outer shell have 2 spots to fill. So things like oxygen. And yeah, well, we won't go much further. There's not a lot of those in there that you need to know, etc. So look, there's some common cations and anions that we can look at, and you'll do some practice on those. But I hope this video has been helpful. Talked about ions and how they form, and yeah, see you later.